All right, problem number 4, got 3 parts. It says, suppose a simple random sample of size n equals 1,000 is obtained from a population whose size is, big N is 2 million, and whose population proportion with a specified characteristic is 0.44. We're going to complete parts A through C. And part A wants us to describe the distribution, the sampling distribution of p hat. And if you look at the answer choices, all of them are telling us that it's approximately normal, and we just have to figure out the correct mean and standard deviation. So what this is saying is that the conditions for normal have been verified, so the sample size is not too big and independence is going to be confirmed, and the characteristics state that the sample proportion mean is going to be equal to the true proportion mean. So all of the answer choices have the correct proportion. It's the standard deviation that we have to figure, and you can see they're all rounded to 4 decimal places. So with this problem, we just have to figure out the standard deviation. And remember, the standard deviation for a sample proportion is equal to p times 1 minus p divided by n, and this is all under the square root. So in this case, we have 0.44, that's our p. If we do 1 minus 0.44, that'll be 0.56, and then our n was 1,000. So we're just going to find out what this is equal to, and that will give us our standard deviation. I'm going to do second square root. I'm going to put the top in parentheses. So it's going to be 0.44 times 0.56. And we're going to divide that by 1,000. And as you can see, that square root bar is extending, meaning all of that is still under the square root. All right, so upon completing that, we got 0.0156, which will round up to 7. So 0.157, and that would be the first option. Okay, so part B wants to know what's the probability of obtaining x equals 470 or more. So this time we have to use the definition of p hat to figure out what this is asking. So we're saying x greater than or equal to 470. And ultimately we're going to do this in StatCrunch, but I just want to kind of go through the setup. So remember, x divided by n is your p hat, and that's what we're doing sample proportion. So we're looking for this to be greater than or equal to 470 over 1,000. Okay. So when we convert this to a decimal, x over n is the same thing as p hat. So we're saying now, what's the probability that the sample proportion, and when we divide by 1,000, we get is greater than 0.47. So this is what we're actually looking at. And then from here, we will convert to a z value. So let's go through the whole setup. P, probability that p hat minus the mean, and they've been using mu p hat, which is the same thing as p. I mean, you can just as easily just put a p here, divided by the standard deviation. This is the formula, p 1 minus p over n is greater than or equal to, and the numbers we will be using is 0.47 minus 0.44, and then it would be divided by this calculation, which we just got, and we rounded to 4 decimal places, which was 0.0157. So we would do this, we would come up with a z value, z greater than or equal to some number, and then we could use the table to figure that out. But actually, let's go ahead and do that since we've come this far. Let's find out what the z value is. 0.47 and then we're going to divide by 0.0157. So we get a z value of 1.91. Okay. So what this says, if I have a bell curve, 1.91 would be over here on this side, and we're looking for greater than the area to the right. And so all I need to do is pull up a Z-chart, which I guess we don't have a Z-chart listed, so I guess StatCrunch would be the best if we don't have one on hand. I do believe I've added one to our Chapter 7 material, standard normal table, so let me just use this anyway. Area to the left, so I can just look up negative 1.91. So we're looking at 0.0281, 0.0281. But most of the time I'm using StatCrunch 0.0281. That's the answer we're getting from the Z-chart. Since the system is only providing us with StatCrunch, let's go ahead and make sure we get the same over here, and I'll just use that moving forward. Normal, the mean, 0.44, standard deviation, 0.0157 when rounded. We want greater than 0.47. Okay, and you get this 0.0280, and ours is just rounded because of approximation. So 0.0280, I think we'll accept that as well. 0.0281, they're very close. And then part C, what's the probability of obtaining x is equal to 420 or fewer? So we want 420 or less. So if we find out what that value is, if we apply dividing by n, doing the proportion, we end up with p hat less than or equal to, divide that by 1,000, and you will get 0.42. And so I'm just going to use the same thing and let StatCrunch compute with 0.42. So this time we want less than or equal to 0.42. Mean and standard deviation are still the same, and we get 0.1014 when rounded. 0.1014.